the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
For me to wish everyone good luck on their finals. This is our last seminar for the semester, so good luck to everyone. I'm going to introduce Dom, who will be moderating the panel today. And then she'll introduce the speakers. Dominic Lukanoff is the Executive Vice President for Corporate Affairs, EHS, and Sustainability for Yuganu Corporation. This is also the sponsor of our seminar series, so thank you. Besides that, she also serves on the Board of Advisors for the Schaefer School of Engineering and Sciences at Stevens, as well as having over 25 years of experience with the EPA over a number of geographic regions and headquarters in various program development and management roles. So I will turn it over to Dom now, and we can get started with our panel.
Hey, good afternoon or early evening. And pleasure to join you guys again. Hugo News also been delighted to help sponsor these series. And of course, I'm wishing you all good luck with the end of the semester. But, we want to remind you through this seminar why you are focused on sustainability. Whether you look at it and call it job security, or you realize that we are finding out more and more about the problems that we face, that we've created in terms of threats to our environment. This particular seminar is going to focus on yet another emerging contaminant. There are two forms of it. The one that we're really going to talk about is, the one when, of course, what happens when it oxidizes and it becomes more toxic in the environment. And of course, there's continuing research. Why should you care about this? Because you can solve it. As we start to look at how to produce different materials in the supply chains from a sustainability standpoint is, how are we thinking of that seventh generation? Whatever we're producing today, we need to make sure that it does not harm the environment tomorrow. In fact, in many cases for remediation, we've produced solutions that ultimately we're now trying to address as they've created toxic impacts on the environment. One being PFAS, which was an anti-flame retardant for safety purposes, and now is very pervasive in the environment. And I'm sure we probably had a seminar on that. So with that, I'd like to welcome our speakers today and thank them for giving their time. Dr. Seth Brown is Executive Director of the National Municipal Stormwater Alliance. He'll share with you what NMSA does, and it's happily, as someone who's been focused on the importance of stormwater management and now greener forms of stormwater management for decades, appreciate the work that NMSA is doing. Many of the toxics that we're talking about in our water bodies, in our groundwater, many times, in fact, 6-ppd is through runoff. And thus, again, the importance of stormwater management. He's going to talk about what NIMSA is doing, the research, the source, the impacts, and start to get into some of the regulatory requirements that are coming about, starting out in the Northwest because of where these impacts have oriented themselves. But we will also hear from Chelsea McDonald, who is a clean water campaign manager for the Waterkeeper Alliance, which is an international organization. You may have heard of water keepers, bay keepers, river keepers, who protect many water bodies around the world. In fact, bay keepers and water keepers can take enforcement actions, and many times it's necessary, in fact, to have these shepherds at ground level working with communities, realizing the types of impacts that are happening. So right around you, the Hackensack Baykeeper, of course, the Hudson Baykeeper, the Delaware Baykeeper, you're going to hear more from them in terms of why 6-ppd, 6-ppdq is a toxic impact to fish, but also what they're doing to make sure that the bleeding is stemmed, get rid of it, look at substitutes, but then how do we address what's already there? We're gonna, I'm just gonna quickly overview, and then the speakers are gonna go into a lot more detail on all of these aspects that I'm just sort of hitting of, what's 6-ppd. It's an anti-degradant that's used in tires since the 60s. It's also to prevent oxidation, tires wearing down, to sustain them. Again, this was to sustain and keep the tires safe, right? Because it breaks down the tread, prevent that breakdown. Well, at this point, and with some impact on roadways, it starts to crack, it starts to break down, and it's the oxidation of the 6-ppd, that 6-ppdq. And by the way, there, for those who have taken chemistry, Dr. Nunez is on. I have to, throw some to her chemistry background. These are aromatics, and if you've heard of PAHs, polyaromatic hydrocarbon, we found that those again occur. They are toxic to the aquatic environment, and there was a lot of work done in the Chesapeake Bay and other water bodies on these. So, stormwater, it has been identified as a key pollutant. What happened is over the years, particularly in areas that have depended commercially on whether subsistence fishing, commercial, aquaculture, coho salmon populations have been diminishing significantly for likely over, it's been tracked well over a decade. And a study was done to figure out what was the leading cause. There have been many suspects out there in terms of urban toxicity. It's called urban runoff mortality syndrome because salmon, they knew it was affiliated with urban suburban runoff, but specifically what in that runoff was causing the salmon to die was the question. And a study was done in 2020, late 2020, 21 was published, and was able to actually isolate the 6-ppd, 6-ppdq, and low concentrations of it to be the causal link to the mortality and the death of thousands of or more of the salmon, but also rainbow trout. This is not limited, obviously, to the Northwest. It's just because the Northwest has been focused on salmon. It's a global impact. As I mentioned before, when tires wear down, the particles they oxidize, they contain 6-ppdq. That's been determined to be the toxic aspect of 6-ppd. It's been found in dust. Also, the air deposition, USGS has a model that shows these exposure pathways, and they're seeing them in air as well as in water, and of course, throughout the ecosystem, particularly in these aquatic species. There's still studies ongoing. Toxicity as low as 0.04 micrograms per liter, but certainly fatal at about 1 ppb. And you'll hear more of that, and more that's under investigation, including by EPA. From a human health standpoint, reproductive impacts, in fact, they've been found at the highest levels in pregnant women, but of course ingestion, and of course subsistence fishing, and why there's a concern for tribal populations and environmental justice concerns, coastal communities that eat, significantly more amounts, and of course ingestion, greater concentrations. So food and water safety is an issue. Again, why we're focusing on stormwater, and there's a stormwater role, and you'll hear more about regulatory efforts, EPA rulemaking. It does remain in stormwater for a number of days, it's been found, and then of course mitigation strategies, including the use of green infrastructure, and now one of my favorite topics, biochar, absorption technology, important when you realize that it's not just these toxic chemicals present, but many others as we're discovering. And it's very hard to target them individually. So as we find the ability to to beneficially reuse, you see compost. However, compost leaches, but compost and biochar are actually a nice combination. But that's happening now. The use of compost amended biofiltration in green infrastructure. Seth's going to talk a bit about that, as well as finding alternatives to 6-PPD. There's no suitable alternative that's been found yet for the tire safety. However, there's been a coalition of tire-related manufacturers who have identified quite a few safer alternatives to 6-PPD. So it's not like everybody's waving their hands and saying, there's no other alternative to use as a substitute for tire safety. Pretty soon they're going to have identified what these are, and pretty soon you're going to see states like Washington and California requiring those substitutes along with additional monitoring. So with that, I'm going to turn it over to Seth, who's going to provide an overview from NMSA's perspective and what's been happening, realizing he's been in touch with quite a few experts working on this topic. So, Seth.
Thanks. And as far as sharing, I need to somehow, Khalid, I don't know how we can.
I think I have to, how do I, yes, I'll, hold on.
Yep, as soon as you stop, I think I can start sharing.
I just have to stop sharing.
Mm-hmm.
There we go.
Okay, and then I will share my screen. You guys see that?
Not yet.
Yes.
Yep.
Okay, cool. All right. Well, thanks for the introduction, Dom, and thanks for having me as part of this discussion. And frankly, a lot of what I'll talk about, Dom's covered a lot of it. I'll get into some more details and to provide some context on that. So that was a really good way to get into this topic. So my name's Seth Brown. As Dominic said, I'm the executive director for the National Municipal Stormwater Alliance. We're an organization that focuses solely on stormwater runoff impacts and management and whatnot. And I'm located in the DC area, Northern Virginia area. We represent 26 state stormwater organizations covering a total network of 4,400 communities, all who focus on stormwater management. So talking about runoff and the impacts from that is right in my wheelhouse. And this is some information I've shared in a couple different contexts recently, so I'm sharing this with you guys as well. But I've been doing some work with AASHTO, which is the American Association of State Highway Transportation Officers, basically the state DOTs, as well as some other organizations on this topic. So I thought I would share it with you as well. I will say for folks who are getting ready for your finals, I also teach a class, so my students are also going in that mode. They're wrapping up the semester, and I know that it's a stressful time. So, but I'm sure you guys will make through it, and we've all gone through it. So I'm sure you guys will do fine. Just real quickly, what I'll talk about, I'll talk a little bit about emerging contaminants, generally speaking, and I'm going to focus on roadway runoff, specifically in this discussion, because as Dominic talked about, the role of tires as a gateway to or pathway or vehicle into impacts from 6-ppd. Obviously, roadway runoff is associated with that. And I'll dig into that even more and the topic of tire and roadway wear particles and how that relates to 6-ppd. Talk about some of the basics of 6-ppd, where we are today with treatment, research needs, something to think about for folks who might be thinking about ongoing areas of research in this area. This is a very rich area for research, so I would strongly suggest looking at that. Then I'm going to talk about some things that our organization is involved with, our centers of excellence, ASTM, which is a standards and testing and materials organization. They set all the testing standards across the world. It's international. And our STEP program, which is our testing program. So anyway, that's what I'm going to cover. Before getting into the details, I wanted to, we were talking before earlier in the day, and I put this together, this slide just today, because Dominic was referring to all the runoff that comes off in urban areas as toxic soup. And that's true. There's just so much stuff in there, so much, obviously, contaminants, pollutants, and whatnot. And it's just to put in context, think about, we've got 85,000 chemicals, for instance, listed in, or as part of the TSCA program, the Toxic Substance Control Act, and there's 55 million, total available that have been registered overall. So the point is that this is all over the environment. We're just talking about one family, but there's obviously so many others. So I would just want to make the point here is that we have to think, I'm sure for sustainability, you're thinking about holistically and globally with these issues, that the sources for a lot of these chemicals are from all over the environment, from industry to wastewater, to agriculture, to household items and whatnot too. So we're going to be focusing on one. I just want to make sure that we keep in perspective that the fact that there's a lot going on at once, frankly, that we can't hyper focus too much, but we're going to, because we're focusing on this one specific aspect of emerging contaminant. And then, in highway runoff, it's some of the most polluted runoff that you'll see. And, because think about all the roadway wear, obviously from particles, we'll talk about that. Those turn into, they're a form of microplastic, but there's also brake pads that have copper in them, for instance, that's heavy metals, zinc that are in tires as well. Dominic talked about PAHs, also the oils and whatnot that are associated with fluids with vehicles and whatnot, oils and brakes, oil and grease brake, and all these other things. There's a lot going on in runoff. We're going to focus on these tire and roadway wear particles and microplastics specifically. But again, think about the fact that emerging contaminants, a bunch of them here. Let's see where I am on the camera. There it is. If you have a bunch up there, then we're focusing into roadway runoff, and then even within roadway runoff, we're talking about this one specific thing. So just keep in mind that there's a bigger picture here. But this issue is big. When we're driving, and especially thinking about, we're moving from combustion engine, oil and gas, that type of thing, to electric vehicles, right? We're seeing that happen. It's going to continue to happen. It's going to, especially in the context of sustainability. Well, one of the things to think about is how heavy are the cars? They're heavier. Batteries are heavy. Maybe they'll get light over time and we get better technology, but as is today, those batteries put a lot of stress on suspensions and tires, and that whenever you're driving, you go around a corner, whatever. Our asphalt and our tires, they're designed to wear down. They're not designed to be, if they didn't have that ability to wear down, then we'd be sliding all over the place. I'm from Minnesota. I grew up playing hockey, and I can appreciate the benefit of having something that slides around, but we don't want this to slide around, right? We can't have that. So we're thinking about just how much wears down, 10 to 15 or 16 or whatever percent of the weight of a tire life. That's how much of that tire actually wears off. And so you have all these particles that wear off. And there's also little, every time there's that friction, there's a lot of tire that wears off, but there's a little bit of that asphalt, which is it's called a wearing surface for the reason, because it wears down and then you have to replace it. I'm sure you guys have seen replacement. So that's why it's called tire and roadway wear particles. And if you think about it, there's 3 billion new tires produced each year, and how much of it becomes waste too. It's just an enormous thing. And we're seeing, obviously with more and more countries driving more, and we're seeing, more development overall, this is becoming a bigger issue, not a smaller issue. And in fact, this might be one of the, the top sources of microplastics in the environment. It's been estimated with these particles. It's a specific type of microplastic, but it's been estimated to be like a third of all microplastics in the ocean. So this is a big deal, and it might even start to be at the same level when you look at total mass and overall globally as like pharmaceuticals and pesticides. These are huge. So this is not a minor issue. While we're focusing on one thing, it's not a minor pollutant type. These particles are, they're kind of bimodal in nature. So there's some that are very fine. They tend to be in this like very fine. We're talking about just maybe twice the size or twice the diameter, the width of a human hair. And then we have coarser particles. And again, that has to do with, because some of it is related to the tire, some of it is related to the roadway. So that makes it difficult. If it was all uniform and very consistent in size and makeup, then it would be a lot easier to monitor and to manage and treat. But that's not the case. There's actually, it has these bimodal kind of characteristics that make things a little bit tricky. So again, some of these particles are like microplastics or nanoplastics. Those are really small particles, behave that way. But again, others don't. So again, that makes it challenging when it comes to coming up with the right treatment processes to target this pollutant type. And because they're dense, these tire wear particles are denser than fresh or estuarine water. They sink, right? They're more dense. They're going to sink down, and they become entrenched in sediments, and especially aquatic sediments. That's where a lot of life is, right? So we have an outsized impact on aquatic biota, because these stuff gets entrenched in the environment where the bugs and the critters, which are the basis for a lot of ecosystems in the aquatic environment, that's where they're from. Taking a step back about what's the source here, how does this work? We're talking about the use and emissions part. So when a tire drives down the road, we generate these roadway these particles, and that gets flushed down to drainage systems, and then that gets obviously it ends up in our waterways and has impacts on aquatic biota. And Dominique's talked about that, especially the impact to salmon. But I think we're seeing broader impacts, and I think we're going to see more in the future. And again, we're not going to get into all of this, but just keep in mind, thinking about sustainability in a broader context, that even the production and the reuse and the disposal of these of tires themselves, that whole aspect or that life cycle, they all have some type of generation of pollutants of their own characteristics. And the dynamics here, or the aspects are, what are the fate and transport? How do they move around in the environment? How do they dispersed? How do we mitigate for them? What are the risks associated with the different forms of pollutants related to tire and roadway tires and tire and roadway wear particles? So there's again a broader picture here. I just want to make sure that we're all seeing that there's more to it than just the specific roadway side of the particles that come off roadways. As far as the impacts are concerned, again, because getting back to the runoff set of things and how these particles get entrained in sediments and soils, that means that there's a larger scale of impact on ecologies that are in these areas. So this has an outsized impact from compared to their volume or their loading than other types of more easier to manage and understand types of pollutants and sources. These contaminants associated with tire and roadway wear particles. Again, Dominique talked about PAHs, polyaromatic hydrocarbons, and 6-PPD. So this is where we get into the 6-PPD through the tire and roadway wear particles. And the reason that we're talking about this in the context of runoff is that, these particles often, it requires a storm event to mobilize them because they do get entrenched in the aquatic systems downstream. So this is how these all tie together. So Dominic talked about this a little bit. I'll talk a little bit more about this, that 6-ppd is the name, or the common name, I guess, for the longer name of the chemical that is added to all sorts of products, but especially tires, to keep them from degrading. So you can see on the right here, if you have 6-ppd, you can see that, and this is a lot of this information is from the Washington Department of Ecology because of all the research they've done there. But on the left side, you see with 6-ppd a piece of rubber that has been, it's been artificially worn in a lab. It's the same amount of wear is done to a piece of rubber that, or a chunk of rubber that has not received that 6-ppd, and you can see the cracking and the breaking down. So obviously, it's really beneficial. It increases, as Dominic talked about, it increases the tire longevity. And that's a beneficial thing because it reduces the number of tires that end up in landfills. We don't go through as many tires. It's also safer. We don't have as many blowouts in our flat tires as we used to have. So there's a safety benefit. There is an environmental benefit that it reduces the total number of scrap tires out there. But we're also seeing it comes at a cost, right? And what 6-ppd becomes acutely toxic is when it's exposed to air, reacts with ozone, and becomes 6-ppd quinine or 6-ppdq. So that's the specific form of the chemical that is lethal to coho salmon, as been talked about, and it can contaminate water systems as well. And I just want to stress that we're just now understanding what this is about. So there's a lot more. There's a lot of research going on. I'm originally from Minnesota, so I keep in touch and I do some work in the Minnesota area research-wise. And there's ongoing research right now looking at the impacts, for instance, of 6-ppd on fish that are local to that area. Because obviously, you think about just from an economic standpoint, it's really important that fishing is, not seen as something that could be toxic, in a state like Minnesota. So it's important for them too. As far as treatments that are concerned, Dominic hit the nail on the head. This is a lot of this information again is from the Washington Department of Ecology, who started to look at how do we manage this. There's a lot that they don't know, but they're starting to look at what seems to be a better approach than others. So they're seeing for treatment, for instance, that there's better or higher potential treatment efficacy when we're talking about things like infiltration, bioinfiltration, those types of things. And as we get into like sediment filtration and filtering treatments is less effective. And of course, if we have BMPs that are not in the transportation corridor, they're not going to be as effective. We can also think about just trying to remove the 6-ppd from the environment itself, before it gets washed downstream and it has to be treated. So that's called source control. And those are things like street sweeping, cleaning of roadside ditches, and cleaning out pipes and whatnot. So it's a lot of a maintenance type of thing. That seems to be the most effective. Even things like wheel washes on construction sites, for instance, or even education outreach that have some kind of efficacy. But again, this is initial. These are early days. And we were thinking about things about like bioaccumulation. Does this bioaccumulate as it's being infiltrated into a bioretention facility? How does that work? How do we dispose of that? How do we to get rid of it once we've captured it? And on the source control side, it's really not. We really don't know how effective any of these, street sweeping types of or other types of source control practices are. So again, these are early days, and again, there's a ton of research needs. We need to know a better understanding fate and transport. How does 6-ppd move around? How long does it last? How long does it remain bioavailable and toxic? How is it bioavailable and toxic in different types of environments, whether it's anoxic or not? How warm? What's the pH of the receiving waters? What's the temporal distribution? When it's delivered and generated during wet weather events, during rainstorms, how do the loadings change over the course of a storm, as an example? What's the distribution of particles, and how does that relate to the loading of 6-ppdq? specifically. And of course, the big question, and then Dominique's, has talked about this and may talk about this some more, is the effective treatment. What's out there? What technologies can we actually use to get ahead of this? So, again, as Dominique alluded to, there's alternatives being considered. And again, because these anti-degradants they're really essential for safety and tire longevity, it's a really good thing that we find alternatives. But when we do this, we need to make sure that they're safe. They're not worse than what 6-PP already is, and that's that the alternative is not more impactful to the environment and to aquatic biota and humans, of course. There is an ongoing effort to find alternatives out there. A lot of it's being led in, as Dominique talked about, California. They're the leader in many ways. Washington State is also involved with this. And the U.S. Tire Manufacturers Association, USTMA, has released an initial report earlier this year about what the initial alternative analysis results are. And they found 60 potential candidates that they looked at, and there's 7 that identified for the next phase. So there's multiple phases for an alternative analysis. And that's what they're rolling into now, again, to conform with these state requirements. So that's the state of things. I want to talk a little bit about what our organization is doing on this front, so you have an understanding on the practical side what's being done in this sector. We have an organization, our NAMSA, my nonprofit, has a center of excellence. These are areas of focuses that we have, one of which is focused on stormwater testing and evaluations. If you go to stormwatertesting.org, you can see what this is about. But this is a place where we can look at how do things work, how do they perform when we're talking about technologies. So this is really, think about our testing program called STEP is being the kind of the consumer reports for stormwater management and infrastructure. So this is a program that evaluates, we set standards, we test things out, and then we provide some verified data about, hey, this works or this doesn't work as we expect. We also have worked with ASTM. I mentioned this. This is the American Standards and Testing of Materials organization. E64 is the Committee on Stormwater Control Measures. I bring this up because we need students to get involved. It'd be great. It's a good thing for academics to get involved with research. We're getting more and more researchers. This committee is only about 3 or 4 years old, which is relatively young. So we're doing a lot of interesting things, and we just formed a work group looking at treatment and performance standards related to tire and roadway wear particles and associated pollutants like 6-PPD. So there is actual work moving forward in the industry to try to stay ahead of this new pollutant or emerging contaminant. We're doing a lot of other work, and I won't get into all the details here. We're looking at a variety of technologies, public domain practices, including green infrastructure, which is really important. We need to have some more understanding of how those perform. And we're looking at more pollutants, including 6-PPD as well. So there are things going on out there. And the last thing I'll note here is that we are partnered with the University of New Hampshire Stormwater Center and the University of Minnesota. And we received one of the 4 Centers of Excellence for Stormwater Infrastructure Technologies grants that just came out over the summer. And we're going to be focusing on testing of products and treatment, approaches and whatnot, including 6-PPD, we hope. So that's the snapshot of where we're going. If you want to learn more about our organization, you can go here. But I know that we're not going to take questions now. We're going to wait till the end. That's correct, right, Dominique?
Yep.
Okay, cool. All right.
And great opportunities, Dr. Nunez, for the Center for Sustainability at Stevens. So maybe some follow-up.
Yes, I'd like to hear how students can get involved in that, so maybe we can connect.
Sounds good. That
offline
sounds
on
good.
that.
That sounds
Yep.
good. Okay, I'm going to stop sharing now so we can move on to the next speaker. Is that correct, Dominic?
I'd like to introduce Chelsea McDonald, who's the Clean Water Defense Campaign Manager for Waterkeeper Alliance. And Chelsea works with a wide range of stakeholders to defend and enforce clean water laws, along with standards and permits. And I think we're going to see, what happens to MPDS, pre-treatment, industrial pre-treatment permit, in terms of what's going into those sewers, as Seth indicated. There's already some regulatory requirements coming along as relates to 6-PPDQ and monitoring for those permits. Chelsea grew up in a small town in Colorado. I imagine beautiful environment, probably some pristine streams. And it actually helped to forge her value for the environment and water as a resource and its foundational importance to communities. Prior to joining Waterkeeper Alliance, Chelsea worked at the Department of Justice in the Environment and Natural Resources Division and as a staffer in the United States Senate. In 2023, she received her JD from Georgetown Law School and as a graduate of the evening program, also her BA from Lake Forest College in political philosophy, sociology, and anthropology. All important areas of discipline to better connect how we kind of get the equation right. So with that, Chelsea, thanks for joining us. I'll turn it over to you.
Thank you so much, Dom. So I don't have slides, but if you watch this space, I'll be flashing the answers to whatever final you personally are worried about the most throughout the presentation. Obviously, that's not true, but I am excited to talk to you guys, especially because it feels like a lot of my career is dealing with science once we realize it's a problem, versus being able to really think about science before the genie has got out of the bottle, so to speak, before every single tire we know is a problem, before dealing with these things on such a large scale. As I said before, I'm the Clean Water Defense Campaign Manager for Waterkeeper Alliance. What that means is I work to push forward advocacy on a bunch of different issues of things affecting our waterways. Waterkeeper Alliance is a unique organization. We're a global movement uniting more than 300 local community-based nonprofits. As Dominique said, they're often called like the Puget Sound Keeper or Hudson River Keeper, and they're spread throughout the world, focusing on citizen action for the issues that affect their specific waterways, from pollution to climate change. The movement patrols and protects nearly 6 billion square miles of rivers, lakes, and coastlines in the United States, Europe, Australia, Asia, and Africa. And the way in which that works is those water keepers are going to be on their rivers or their waterways very frequently. They're often going to be the first people to see issues. In this case, I know that our Puget Sound Keeper has been aware of what they called zombie fish disease for, I think, decades now. And as Seth alluded to, we only really realized that 6-PBDQ was being created by tires, I think, in 2021. So that's decades of that awareness and concern for the coho salmon that then led to the science where we identified the problem. And what I really want to focus on my presentation is then what do we do now that we know there's a problem? What do we do now that we have some science, but also, as Seth said, definitely not enough science? To kind of walk us through what that looks like, I've broken my presentation down into just honestly what each branch of government is doing, and then what Waterkeeper is doing to then help push the US government further on this issue. So I'm just going to start us with the executive branch. For the United States Environmental Protection Agency has been great in terms of the fact that they acknowledge that 6-PPD is an issue and that it is killing some fish. However, when they're thinking about how to regulate this chemical, they continue to push back on the fact that we have limited information available, both for emissions, for how it's being transported, especially questions around what is the human health effects. And so they're engaged, more focused on getting that research, learning more about how is this actually impacting humans? What is this impacting in the aquatic ecosystems outside of coho and some trout species? And while that's incredibly important, right, because to understand the scope of the problem, we're going to need to understand the science. This then also limits, though, what is being pushed forward in terms of regulation, which, in my opinion, is going to be an issue, right, because we already know that this chemical is killing fish, so especially when we see videos of coho, sometimes within an hour. and like very awful videos that you can find online that I debated showing you, but decided you didn't need that at 5:30 in the evening. But right, that these fish are basically suffocating and losing what's going on. And so that's concerning for what that could do for the human body. It's also concerning just for fish ecosystems generally. Um, so EPA though has continued to push forward an action plan that they actually released just 2 weeks ago, which is great to see, like a 4-year plan of research they're going to conduct to address these data gaps, providing updated information to the public, which is a huge part of Waterkeeper's work, as well as finalizing different rules under TSCA that would require more information to be submitted by manufacturers and other folks. So again, it's really getting into what is the information that we need to learn about these emerging contaminants so we can understand a full scope of the problem, which is really important work given how early we are in this process. They're also currently collecting data from the public, basically just asking for concerns around 6-PPD, which Waterkeeper Alliance is engaging in, along with all of our local waterkeeper groups. I shouldn't say all, many of the local waterkeeper groups, for opportunities to raise awareness and do advocacy around that. And if after this presentation you also feel inspired, I would recommend you can also submit a comment to express your concern and just become advocates on 6-PPD today. So that's a lot of what EPA is doing. We engage with EPA as an advocacy group through different stakeholder meetings where we've expressed our concerns, as well as through those more formal comments on the register. And it's about, right, just really kind of emphasizing that there are folks out there who are concerned and need urgency. So really just continuously heightening that argument. In a different branch of government, the United States Geological Survey, or USGS, has also been active, collecting information, doing research, which again is really, really great. However, we're also vaguely concerned with a lot of this research in terms of how much it is tied in with the tire industry, which is a double-edged sword, right? Because as advocates, we're incredibly encouraged by the fact that the tire industry learned about this problem and are beginning to engage right away. They want to find alternative solutions. They're acknowledging that this isn't a sustainable solution, which is really important. But then also when they're so fundamental to finding the alternative, you have to worry a little bit about kind of like a PFAS problem, right? As Seth said, they released I think 7 different like possible new solutions to 6-PPD for alternatives, but a lot of them are like things like 7-PPD or 9-PPD. So that just leads to questions around how much is this just solving a problem for right now? And we're gonna find out now, 40 years down the line, that it's going to be a different problem, or that there's the same health effects. And so making sure that we have folks outside of the industry engaging in this research to make sure that it is actually what's going to be the best for human health and the ecosystems overall, and not necessarily what makes the most sense from an industry perspective, just because of inherent biases when you're trying to navigate all of the different pressures the industry is under. Um, Obviously through no fault of their own, but just the realities of trying to stay financially viable. So then that's also a different agency that we've begun to engage with. In terms of the legislative branch, for Congress, we've also seen really exciting movement in the last year. Senator Merkley of Oregon and Senator Mullins of Oklahoma actually hosted a hearing for the Environmental and Public Works Committee's Subcommittee on Chemical Safety, Waste Management, Environmental Justice, and Regulatory Oversight. And that hearing was held in the summer of this year, which is great to see the Senate begin to have folks come in to ask questions, to think through what are legislative solutions we can have to this problem. For us, we've been thinking about the solutions in 2 pathways forward. One would be finding this alternative, finding a solution so we're not creating more and more chemicals to be dealt with. And then on a different pathway is the stormwater management. How do we deal with what already exists? And also, let's not put all of our eggs in the basket of being able to find a magical solution, right? Being able to find a chemical that can make tires still so safe that they can run on roads for a very long time, but also not have any health effects and not have any environmental impacts. And so instead, let's focus on stormwater solutions as well. Because as we've seen, tires are nasty things for a lot of reasons, from the microplastics to PFAS to I saw today EPA said there was a new chemical that was a problem in tires that I had personally never heard of before. So tires are nasty and we need to find a solution for them for all sorts of different reasons, even outside of 6-PPD. But pushing forward that like first pathway in terms of alternatives, we were also very excited as an organization to work with Senator Merkley on developing language to include in the manager's package for appropriations, requiring the Department of Defense to investigate alternatives to 6-PPD. So a manager's package would be language that's included with a bill that passes through Congress, directing agencies to do something. This is really powerful because then, right, it's going to that problem I outlined earlier of the Department of Defense getting involved in research. So then they are able to verify what's coming out of the agent or the industry research, be kind of just this third party arbiter and making sure that we're finding a solution that makes the most sense for human health, and also just have that transparency that we're able to get as advocates from government in terms of like being able to access information through Freedom of Information Act, or different mechanisms for accountability with the government that we wouldn't necessarily have with private industry. And then finally, one challenge that I think we face in terms of the legislative branch is engaging with this issue and showing that it isn't just a Pacific Northwest issue. Obviously, the coho salmon are a charismatic species. They have a lot of cultural value and significance to the Pacific Northwest. But we find with our advocacy, we've actually had a lot of success with senators from Oklahoma, as well as even in the Northeast and along the Great Lakes, by being able to talk about trout, by being able to talk about the fact that even though we don't know for sure what it's doing in human bodies yet, that we know it's in human bodies. And also, when thinking about, I think everyone thinks about roads. I think no one really, everyone knows you never want to be the person like living next to a highway, right? We have these kind of built-in infrastructures where we know that's kind of bad, but I think especially with tires, when you point out to folks how often tires are being recycled into what's the basis for playgrounds, what's the basis for the turf that their like 10-year-old soccer player is playing on. And then we've had these studies of like the higher rates that that astroturf is putting 60 ppd into bodies from those sources is also going to be a deep concern and resonate more with folks who maybe aren't deeply personally in love with the Puget Sound or have never been there. Though everyone should go there. Beyond that, just talking through other advocacy pathways for the judicial branch. A lot of this is also work that's being done through lawsuits. So lots of water keepers bring what are called citizen suits underneath the Clean Water Act. Basically, a citizen suit allows a nonprofit to act in place of government. So if you feel that EPA has missed an opportunity in litigating against a polluter for pollution, then that nonprofit is able to bring a citizen suit and enforce that action. These are really powerful tools. To my knowledge, we haven't brought any as a waterkeeper movement under the Clean Water Act on 6-PPD to date. However, Earth Justice has brought a couple different lawsuits that I wanted to highlight for you. One they brought on behalf of the Yurok tribe in the Pacific Northwest, which was a petition promoting EPA's regulation of 6-PPD under TSCA, which is actually what prompted a lot of EPA's work that I outlined before. And EPA acknowledges that in their documents, which is great and shows the power of a single lawsuit to really radically change the conversation. Earth Justice has also brought these lawsuits on behalf of the Fisheries Resource Institute, as well as the Pacific Coast Federation of Fishermen, who are also filing suit against the tire manufacturers because of the devastating impact on salmon that they rely on for their livelihoods. So this is again going after this issue both from a cultural perspective for the tribes as well as livelihoods for the fishermen. And both of these suits made their main argument actually under the Endangered Species Act, given the impact on coho, the fact coho have special protections, and therefore these tires then are possibly violating the Endangered Species Act due to the high rates of death we see for those species. And I also just wanted to quickly touch on, before I wrap up, the fact that this isn't just a federal issue. As I said before, lots of states are starting to get involved. Washington State has been a huge leader, given the fact you could see just even from Seth's presentation how much of the diagrams and like data that they're putting out, as well as the fact they've been regulating on this issue, putting forward bills and laws in their jurisdiction regulating 6-PPD. We've also had regulation coming from the an investment in this topic from the Northeast with the Delaware River Basin Commission, which is made up of Delaware, New Jersey, Pennsylvania, and New York, who have also been collecting data on the 6-PD in their watersheds from different sites and have found that there's stormwater runoff events that have been raising levels of 6-PPD in the Delaware. So I think my overall message is that we're seeing a lot of engagement, even though it's early days on 6-PPD, which is great. And as advocates, we're really trying to use the science that we have to push forward more science, as well as using what are reasonable conclusions around trying to get regulations now for stormwater, especially given that we know that stormwater management and support is so huge and influential, not just for 6-PPD, but so many other toxic chemicals, and really pushing forward on those efforts as well. And I will stop there.
Great. My mind's sort of going because I'm glad that you mentioned